Hi guys. Starting from today, I think I will we will try to solve questions which came in maybe TIFR, NET, GATE, CMI, SI, maybe from JEE Advanced as well. Whatever I come across, I will try to solve and yeah. So I think this question it was given I think in like it was given I think it came in TIFR. It came in TIFR 2021 in part B. So this question came in part B. Basically the true and false. It is a true and false question. So let me erase this. And I'm sorry because I'm writing this with a mouse. So it like yeah. Uh, uh, Now in the question given is given a linear transformation T from Q4 to Q4. There exists non-zero proper subspace V of Q4 like such that T of V is a subspace of V. Basically like T of V is a subspace of V, meaning that V is T invariant, right? So V will be T invariant. V will be T invariant. Yeah, you get the idea. Uh, so now it is very important to notice that it is given that it's a non-zero proper, non-zero proper subspace. Okay, so one might be tempted to just think that okay, like that we know that if T is any linear transformation to a V to V, then automatically like car T and image T is automatically car T and image T is T invariant. Both are T invariant. So yeah, so both are T invariant. But what might happen is that suppose we have car T to be zero, right? Car T to be zero, then it will be an injective map, and since it's T is, of course here V is FDVS, finite dimensional vector space. So if T is injective, then T will be surjective, basically a isomorphism, bijective, right? So image T will be the whole space. So like we might not get any non-zero proper subspace. So basically we have to find a T such that there does not exist a non-zero proper subspace, right? Okay, so let me just erase this and let me write. So so basically take T to be right. Let's say the I mean I mean suppose right, suppose the minimal polynomial of T is, let's say, x to the power 4 plus 1, right? So basically yeah, we can get such T because I mean we just need to the we just write the companion matrix for T. I think it will be the companion matrix for T will be so basically we will write 0 in, so this, and x to the power 4 plus 1, so basically this will be minus 1, right? And this will be 1, this will be 0 0 0, this is 0. Companion matrix, it shifts by 1, this will be 0, this will be 1, this will be 0, this will be 0, and this will be 0, this will be 0, this will be 1, and this will be 0. So basically first, and we know that in a companion matrix minimal and characteristic polynomial are equal, right? So if we have linear transformation with respect to the standard basis, of course. Okay, so it will be standard basis, let's say take the say beta something like that. So this will be the this will be the matrix, right? And we can see here that E1 goes to E2, E2 goes to E3, E3 goes to E4, and E4 goes to minus of E1, right? So this will be our, now if we can show that the in this case we can clearly see the minimal polynomial will be irreducible. Not the characteristic polynomial will be irreducible. And why this is let me just erase this once again, uh, or let me just go to a different page. So yeah, so, and this will be because, right, this is cyclotomic, and any cyclotomic polynomial is irreducible in Q. One can think of it like this, or we can just also use basic methods. like we know one such, suppose like uh, let's say, right, if suppose fx belongs to a field capital, I mean, yeah, suppose this is a field, and this is a very common result. And so if, let's say, like for any c, f of x plus c, which will obviously belong to f of x, is irreducible, then it implies that f is irreducible, right? And and okay, so this, now let me just erase this one. So basically we have our fx to be x to the power 4 plus 1. Now, like, so we want to show that fx plus 1 is irreducible, which will be x plus 1 to the power 4 plus 1. And so if this is, we can show that if this thing is irreducible, then f of x will be irreducible in qx. And yeah, so there won't be any, non-zero proper, like t invariants of space, right? Okay, so I mean, of course, the roots, I mean, all the roots are complex, but yeah, it's cyclotonic, right? So, I mean, x to the power 4 plus 1. So in this case, like, we will get, if we expand this, we will get something along the lines x to the power 4 plus something plus, I mean, okay, plus something plus 2. Right here, 1 and 1 will add, we'll get 2. Now we can take a prime p equals to 2, and we can just see that it divides everything and except the, like, the coefficient of the higher, like the highest power, because it's, of course, it's monic. And yeah, this will be some, like 4c1 something 4c2, everything is divisible by 2, and 2 square 4 won't divide 2. So by the Eisenstein's criteria, we can simply say that this is irreducible, right? So so basically we are done, right? So if we take T to be this, like, there does not exist any non-zero proper subspace. So our statement, this statement is false. This statement is false. So yeah, I think yes. Okay.